Welcome to this podcast brought to you by the Vatican Observatory Foundation. I'm your host, Bob Trembley. I'm a volunteer NASA JPL Solar System Ambassador, the president of Michigan's Warren Astronomical Society, and an internet factotum for the Vatican Observatory Foundation. This podcast comes from a recording of one of our monthly full moon meetups with the Vatican Observatory staff and Sacred Space Astronomy subscribers. Sacred Space Astronomy is the Vatican Observatory's online community. We have several astronomers and scholars who write articles on our website about astronomy, space science, and faith in science. Every full moon, the Vatican Observatory Foundation hosts a Zoom meetup for our Sacred Space Astronomy subscribers. Typically, our guest will be a member of the Vatican Observatory staff or an affiliated researcher, and they'll tell us about the research they're doing and the journey that led them to the Vatican Observatory. Brother Guy Consolmagno, director of the Vatican Observatory and president of the Vatican Observatory Foundation, will typically talk with our guest, and our Sacred Space Astronomy subscribers can ask them questions. This podcast was taken from the Full Moon Meetup on Friday, January 6th, 2023. We had several members of the Vatican Observatory staff talk about a wide range of interesting topics.
So welcome everybody to Feast of the Epiphany, as somebody once put it, the patron saint of astronomers. For this special meetup, we're going to have a roundtable of various members of the Vatican Observatory and Vatican Observatory Foundation to give you an update of what's coming in the upcoming year. And we're doing this for two reasons. Number one, of course, we're responding to your requests. When we had a survey recently of what people wanted to hear, somebody had asked for something like this. On the other hand, I'll also confess it's because it is Epiphany, and the first person I asked here in Italy said, I can't do that, I'm going to be with family today. It turns out Epiphany in many parts of Italy is like Christmas. It's the day when the Epiphany witch comes and brings presents to little kids. And there's even a sweet that looks like a lump of coal that you give to kids when you want to tease them about being a bad kid. And those of us of a certain age will remember, the idea of getting a lump of coal in your stocking. One other person who I did ask to be on this was Fernando Comoron, who's been on a number of these in the past. I hadn't seen him recently. And so I wrote to him saying if he'd be interested. And he said, at some future date, but he's been in the hospital the last couple of weeks. Apparently he had a stroke, and he says he's doing fine, he's recovering, but it's going to take some time. He was the one who led our group to a big tour of the observatories in South America, about 6 or 7 years ago. So we certainly keep him in our prayers. Anyway, the other thing I will mention is, along with it being Epiphany, it's the feast of Saint Andre. Now, Brother Andre of Montreal was a fascinating character, and you can look him up. There was a note about him in America Magazine and how it'd be 150 years since he entered the novitiate. So, okay, he's a saint from way back. My mother met him when she was a little girl in Plattsburgh, New York, and her older brother was in a swimming accident. Brother Andre was in the hospital to see kids, and there are a lot of cures attributed to him. My uncle, unfortunately, was not one of them. He died at age 14 in that accident. But at the time, my mom, who would have been maybe 8, got to meet Brother Andre and still remembers him to this day. So my mom, who would have been 102 this year, it makes 150 years feel a whole lot closer than it might have otherwise.
We try to have everything in the dome.
We lost a bit of the audio for Paul Gabor's report on the Vatican Advanced Technology Telescope here. And we usually edit that portion of the meetup out of these podcasts
minus 10
anyway,
centigrade,
but this
which
one
is
was pretty interesting. So
20 degrees Fahrenheit.
Yeah, it's an interesting thing that the instrument itself, the actual camera, is held at liquid nitrogen temperatures, because keeping it very cold will reduce the electronic noise and thus increase its sensitivity. And so one of the jobs of the observer is to fill the dewar next to the camera with liquid nitrogen every night. And when it's really cold up there, the nitrogen lasts a little bit longer. You see, you only have to fill it every 18 hours rather than every 24 hours rather than every 12.
There's that, but all the electronic circuitry runs various systems of the telescope in the dome. It's a bit of a struggle to get equipment that comes with specifications of temperatures lower than freezing. If you look closely at the small print of most electronic equipment that you buy, the specifications are something like 0 degrees centigrade to about 60 degrees centigrade. And if you operate those things outside of that range, the warranty is voided, right? So we kind of do that.
There was also the problem in old days when hard disks were actually physically spinning disks, that those were not warranted at above 10,000 feet because it required air pressure to keep the disk head off the disk. And our telescope is above 10,000 feet.
Yep. And we do have a minimum allowed temperature. I think it is -10. It's written on a piece of paper right in front of the operator's nose, so I don't have to remember it.
Okay, what we've got on board here is a group of people who work at the observatory. We heard from Bob Trembley last month, but he's here to answer questions and to play host to this group. But along with myself, we have Chris Kennedy and Katie Stenke, who are parts of the foundation and can tell you what's going on with the foundation. Paul Gabor and Larry Lebofsky, who are observers, who can tell you a little bit about the telescope. And among the four of us, feel free to throw in questions at any point. What I was going to do to start it off was to start chatting about a few things happening here, or happening at the observatory now and in the coming months. And the first thing I will mention was, of course, yesterday was the funeral of Pope Benedict. And since we are at the Vatican, we were invited to partake in the funeral. But since we're an hour outside of the Vatican, it was not a particularly easy drive. The one from our group who went to represent the Vatican Observatory at the funeral was Father Gabriele Giunti, who's the vice director. And so he concelebrated the Mass along with a group of several hundred priests. If any of you saw the funeral on television, there is a large section of people dressed in white, and he was in amongst that section. And look for the guy with the bald head. He was there, and there was some comment in the press about how the Pope's homily was short. What the press didn't notice was that it was windy and bitter and cold. It was so misty that you couldn't see the dome of St. Peter's from from there. So it was not a day that you wanted to be outdoors for a particularly long period of time. But apparently it was a very moving ceremony, and we remember Pope Benedict, as I mentioned in the newsletter, as someone who was a great friend of the observatories. There are a bunch of things happening in the coming year, and in no particular order, I'd like to have a few people here chat about them. First of all, there's our summer school happening. The summer school affects everybody on board because you guys are funding the summer school. So, Chris, can you give us an update on how well the funding is going?
Sure, absolutely. As you saw from Brother Tom Williams, he has initiated the transfer to you using the complicated means of getting money overseas of around $80,000. And more has come in as end-of-year gifts that have arrived, in the beginning of the new year, but as gifts for sort of the end of the year 2022, which is end of year is always, of course, a big fundraising period for any nonprofit. So I think we're in very good shape for funding. That said, we can always use more help. I think, as Guy, you and I have discussed, not only, of course, does this help to fund the operations of the summer school, it also funds travel costs and incidentals for people, particularly from third world countries, which make up a large portion of this summer school student body, to allow them not only to get to Rome, but and just as importantly, experience Italy a little bit, maybe have a little bit of pocket money. They'll be able to make the most of their month there. So funding is in good shape. You will be seeing, though, in our emails, especially in the first half of this year, appeals for a little bit more help. Travel costs, as I'm sure all of you know, have increased substantially. It's our objective to be able to fully fund the costs of anybody who needs it to be able to attend.
The $80,000 is about what we spent for the 2018 summer school. So if nothing had increased in cost, we would be in good shape. But the two things we're looking at are both travel costs, and also we feed the students.
Yes.
And the cost of food, especially in Italy, has gone up significantly in the last 5 years, just in general inflation that most of us have seen. So we would be much more comfortable if we were able to top 100,000. And if we can get to 125, which is our goal, then we would be able to also provide a lot of other extra support. At the moment, we're asking all students to support themselves to some degree, and some students, if possible, to all degree. The more money we have, the more support we can get in. The other thing which I'm very aware of is the number looks great, but about half of that was money that we had raised for the 2020 summer school and never spent because there was no 2020 summer school. And so we're keeping an eye on that. And with luck, there would be a little surplus left over that we could then dedicate to the 2025 summer school. One of the things that I'm planning on doing at the end of the month is to write a special newsletter sort of thing sent only to the summer school donors so they can get the list of the students, where they're from, what they're up to. And eventually we may try to actually connect individual students with individual donors, but that's something for the future.
Just before we end talking about the summer school, I just wanted to chime in that the alumni of the summer school are amazing people. Brother Guy and Justin Whittington and I went a few years ago with one of them up to JPL and saw the perseverance in the clean room and, just amazing stuff like that. And a good friend is a teacher at Caltech, and she's got a lunar orbiter, Bethany Ellman. She's only, 41 years old and already has something going off into space in June and teaches planetary geology. So, those are just the two that come to mind immediately. It's an amazing group of people. Besides, was Fernando Comaron?
He was
one
an
of the
early
students.
He was an early student.
It's an amazing international group of people, really.
Those of you who remember the image of the black hole, the shadow of the black hole, the scientist who came up with that was Heino Falke, and he was a summer school student in '93. And the Dean of Science at Cornell now is Ray J. I can never say his last name, a long Indian name. And he was a summer school alumnus. So we get some really remarkable students who remember the Vatican fondly. And it really makes a huge difference. There's a scientist who's been living with us in Tucson who got his doctorate in meteorology. He's from Indonesia. He's a young Jesuit. And for 6 months, he's back in Indonesia working on a Jesuit program called Tertianship, which is his last program before he takes his final vows. And he just sent a photograph of himself being a meteorologist now with a doctorate with a young scientist at the Meteorology Center in Indonesia who happened to be a summer school student from 2003. And she shifted from astronomy into meteorology. We're going to hope to shift Bayou from meteorology into astronomy. But yeah, you just find these students all over the place. They're quite remarkable. Actually, Katie, since you're on here, there is a big Catholic / outreach conference in Los Angeles happening at the end of February that I guess we're going to be part of. Can you talk about that?
Yeah, to tell you the truth, I've never been to it, but it's a huge one. I tried to get you to be one of the speakers years ago, but they were already booked and, I was late. Anyway, it's held, I think, down by Disneyland in Anaheim, and it's a huge religious educational congress that's kind of organized by the Diocese of Los Angeles. So we're planning on participating. Chris Kennedy and I will be working on it along with one of the board members, Pam Snyder, who's been at it for other times for a different organization, and maybe Rich Friedrich, who was chairman of the board of the foundation for many years. Part of this is because he brought it up that it would be a good idea. So we'll have a table there and exactly what we're going to do and not do. We'll figure that out. Chris, you might even know more than I do. We'll be meeting next week with this group to figure out everything we're going to do.
Looks like a couple of people in the chat are familiar with this. Michelle Francel writes, it's a fabulous event. I'm glad we'll be there. And Francis Agnoli has a link to it. It's not free. We don't just show up with a table. We actually have to pay our way in. This is something to remind those of you who can support us that this is part of the work we do to show the world, especially the Catholic world, of how the church supports science and the kind of science we do.
Yeah, we'll try to have something of like video things running, and we'll have materials to give out. And eventually, I think we'll try to get a major speaker at the Congress. I think that would be a good idea, but that's a whole different thing.
They have to know us, we have to know them before we can get
exactly.
Yeah, there's, of course, research happening. Paul, you mentioned a little bit of the research that Chris Corbally is doing. What other research is going on in Tucson right now? Start by telling us about how you got your name in the New York Times recently.
Oh, dear. I've been involved with the leap second debate for quite a while, since 2011, in fact. If you are unfamiliar with the leap second debate, that's great. I always think that the best policy is not to publicize the matter too much, but essentially this is a mechanism that tries to maintain a certain coupling between civil timekeeping, which is done typically with atomic clocks, and astronomy. So the atomic clocks obviously run at their pace, uniform pace. And if you want to couple the civil timekeeping with what the Earth does, it's spinning, right? And you would think that that spinning is uniform and at the same speed all the time. It isn't. It's actually slowing down. Sometimes it actually speeds up a little bit and then slows down again. We don't really know why it's doing that exactly, but the point is that there is a mechanism since the 1970s that keeps these two things connected. And the mechanism is very simple. Once in a while, you add a second. That's called the leap second. So now the question is, should we maintain this mechanism or should we just forget about it? Because there are people who don't like it, various branches of human activity where breaking the rhythm of 60-second minutes with once in a while having a minute that lasts 61 seconds is considered quite a nuisance. So there have been various people pressuring the international community to adopt a change.
I guess one of the examples of this that surprised me until I read about it were people who are doing deals, buying and selling stocks. And you have to be able to synchronize who's got their bid in first. And
Right.
if you're running on two different clocks, that difference of a second can mean millions of dollars difference to one person or another.
Yeah, it's lots and lots of little details like that in the modern world. Believe it or not, the people who are kind of responsible for timekeeping have nothing to do with either astronomers or actually metrologists, people who deal with measuring stuff. But it is the International Telecommunications Union, people who have nothing to do with this in principle, except that in the 1920s, when this setup was put in place, they were in charge of distributing the time signals, right? Radios. Now it is essentially up to the World Radio Telecommunications Conference that will be held next year to come up with maybe a solution. They've already postponed adopting some kind of a solution many times over. Well, this time round, they have a proposal on the table that came in November from the International Bureau of Weights and Measures, the metrology community, and that basically was the reason why these articles appeared in New York Times. My involvement in the thing is simply that I've been working with the group of experts who sometimes meet. We had, I think, 3 largish meetings over the last 10 years discussing these various options and things like that. And my input usually has to do with some kind of societal impact of a possible change. And that's kind of what I usually talk about at these meetings.
Of course, you are representing the Vatican, who are the guys who invented the calendar in the first place. So this supposedly gives you wisdom.
Exactly. That's my take on it. I always start with calendars and try to use them as an example of how these various changes in calendars have happened and why the society finds them acceptable, and what would be probably a little bit disconcerting. And I maintain that this decoupling is a little bit disconcerting on a symbolic level. If you decouple way we tell time from the actual stuff that happens in the sky once and for all with great fanfare, I think that's a bad idea.
You mentioned in an email to me that you thought that they weren't going to do anything and that GPS time probably going to be what gets adopted by default. I've never heard of GPS time before.
Well, you're using it for the most part. How this works is, from the point of view of various countries' legislation, we are all supposed to be using UTC, the Coordinated Universal Time, which is a product of that bureau in Paris, the Bureau of Weights and Measures. And it is something that has those leap seconds in it, precisely because of those leap seconds and also because of the availability Many people have kind of switched to NTP, the Network Time Protocol, which is what your computer uses, or GPS time, which is what your cell phone uses. Because of this, in practice, most people don't actually use UTC. They use these derivatives that are somehow different. GPS time by default doesn't have the leap seconds in it. The push that is coming from the metrology community, and I sympathize with them deeply, is let's make UTC more relevant by getting rid of the leap second. So sacrificing the leap second on the altar of people actually using the proper UTC, right? As opposed to these informally much more widely used time scales. The main reason why I think that there won't actually be any change on the international level has to do with how the World Radio Communications Conference works. It is a body that has absolutely no way of enforcing its decisions. What does it do? Well, it distributes and allocates radio frequencies to different nations. So this is an extremely delicate thing, and all the decisions have to be consensual because there is no way of enforcing them, right? So this is the principle. They have to come up with something that everybody agrees with. And there is a vote, but if somebody strongly disagrees, they actually won't vote. They will say, okay, we'll discuss this next time. This is what happened 5 years ago when they had the last meeting. And this is very likely going to happen again because we already know that Russia will be against this. Their global navigation satellite system uses a different version of GPS time, and you can't program it. And their global navigation satellite system actually has the software written in such a way that it presupposes that UTC is synchronized with Earth's rotation. And they can't change the software. The way that the satellites are put together, you can't actually upload software to them. So they're not going to be happy with this idea, and I'm sure they'll say no. And if they find some other groups that will say no as well, and then I think the whole thing won't happen. If I were a betting man, that's what I would go for. But the whole thing is just kind of a never-ending story. The first proposal to get rid of the leap second came in 1999. So just to give you a perspective here.
I'll also point out that Stan and Michael have a couple of wonderful comments in the chat about this. Stan pointing out that this goes back to the old, what is the center of the universe? And Michael giving examples for when he was working in Transferred for London, where the time officially started 330 minutes past midnight. Timekeeping comes up in the oddest ways. You probably have noticed that, of course, the days are getting longer, right? Except that sunrise at the moment is later and later still. And that has to do with the fact that our clocks run by machines that keep the clocks running at a constant pace, but the position of the sun shifts around during the year, not only depending on what part of the time zone you're in, but the fact that I think it was 2 days ago, the Earth was at perihelion, it's closest to the sun, which means it's moving the fastest, which means that it has the biggest contribution for the year of where the sun is in the sky at any given moment. And even though it's a few minutes, 10 to 15 minutes difference from one time of the year to the next, it's enough to really confuse people. If the days are getting longer, how come sunrise is still later every day? And those of us who are an astronomer can explain it, but not in a short enough period of time that people's eyes don't glaze over and they go, I don't get it, go away. Life is like that. And to another earth-shattering point of view, Larry, can you tell us a little bit about your work looking for asteroids?
What I do is, in theory, try to save the world from near-Earth asteroids running into us. There are a good number of people who observe asteroids, and many of these come past the Earth. They're called near-Earth asteroids. And there's 1,000, 2,000 asteroids that are considered to be potentially hazardous asteroids. In other words, at some time in the future, their orbits may bring them close enough to the Earth that, as I say, there are no stop signs and no controls in space. So if they're in the right place or the wrong place at the same time, they will run into the Earth. You see that with meteors and meteoroids and other things. but there are a few that are big enough that if they run into the Earth, it could be pretty bad. So basically what we do is there are asteroids that are being discovered, and we found a little niche ourselves, which is to observe, stupidly, very near full moon, because nobody else wants to observe at that time, which actually makes it easier for us to get time. But basically, an asteroid is found, and we do the follow-up of them and hope that we get their orbits accurate enough that somebody in a week or two afterwards can pick them up again, and we get to know their orbits well enough so we know how close will they get the next time they come by the Earth. We've had 3 runs. The first run, we observed more asteroids than we have total for the last 5 years or so. The run last month in December, basically we had for most of the run, we had what are called orographic clouds, which means you are in a cloud that is moving about 30 or 35 miles an hour past you because of the high humidity, etc. So it was a complete washout. Early discussion was with Paul Gabor. The last run, we didn't even bother going up because the snow was too deep. The first night, they cleared the road, but there was basically ice on the dome. And so you couldn't even get to the roof to clear the ice if there was a way of doing it. So wait until next semester.
Right. So there's an interesting little physics, not physics 101, but physics 201 principle behind all of this. Newton's laws say that, if you've got, F equals ma, if you know the acceleration, you know the mass of the object, you know the forces acting on it, you can determine the actual position. To be able to define the orbit of an asteroid, there are 6 elements you need to know. And physics 201 or linear algebra says if you've got 6 variables, you need 6 very careful measurements to fulfill 6 equations that can define the orbit. I remember when I was a graduate student and very, very early on in the planetary science department, the test we had to take before we could go on to a PhD, one of the questions was, what are the 6 variables that define an orbit? And they meant, eccentricity and some major axis, and we had to remember all those 6 elements. But somebody wrote down x, y, z, x dot, y dot, z dot, which is the position in x, y, z space, and then how fast it's moving in x, y, z space. And he's completely right. It's, totally useless for actually computing things, but those 6, in other words, you need to make 6 very careful measurements. When Larry measures a spot in the sky that's an asteroid, he's making 2 measurements. Where it is in the sky in terms of latitude and longitude. He doesn't know how far away it is, so he doesn't get a 3rd measurement. So he's got to make that measurement at 3 different times, minimum, to be able to get an orbit. And since these measurements are never perfect, and the slightest bit of error can really cause a big problem later on, you want to get as many different times when you can make these measurements of these 2 elements in order to finally define the orbit. Am I doing justice, Larry?
And the farther apart they are, the better. In other words, if you do a set of observations on one night, you've got a small arc with respect to the total orbit of the object, but you would like to get it over maybe 4 or 5 or 6 nights. But basically, the farther apart they are, the more accurate your final measurement is.
Gee, Larry, why can't you just go back 6 months later?
6 months later, in general, the object is on the other side of the sun.
Well, what about a year later?
In all likelihood, it is somewhere else because you're going around the sun in 1 year. The object is going around the sun in 2 or 3 or 4 years. So if you are observing it when it's bright enough to be able to see it, a close approach to the Earth, next time that happens might be 5 or 10 or 15 or 20 years from now.
At which point you're not even sure you're seeing the right thing.
Toast. Yeah.
Fabulous. I'm sorry, I cut you off. You had one more point you were going to make.
The one thing that is the hardest to determine is how far away it is. As Guy was saying, you've got the X and Y position, but you don't have the Z away from you, basically. Actually, you have X and Y, but not Z, depending on how your coordinate system is. That is the greatest uncertainty with respect to the orbit. What ends up happening, if you just do the orbital calculations, you know the orbit ultimately fairly well. The biggest uncertainty is where in its orbit is it, which is very important because it's, like, hi, I'm in a car and I'm running along the side of a train, and do you get to the crossing at the same time as the train, just before the crossing, or just after the train goes by? And that makes a big difference as to whether you make it. And that's essentially what happens, is that you've got a train and a car, and are they in the same place at the same time? And that's ultimately, that's the biggest uncertainty, is where exactly where it is in its orbit it is, and how far away it is.
Can I butt in a little bit, Brother Guy?
Absolutely.
There is, in September, it's the 30-year anniversary of the telescope. I think we'll have to do something. I don't know exactly what, but it's, it saw first light 30 years ago. So I think that's a big thing, for at least from our side of, the non-scientific side.
Stay tuned for more on that. I know that I've been talking a little bit with Father Paul Gabor and some other folks in Tucson. So yes, stay tuned to the newsletter and pencil in sometime in the fall if any of you are able to make it to Tucson. We're certainly hoping to have some sort of in-person celebration, really, of all the telescope has done. So pencil in sometime in September, but definitely more to come on that.
Okay, we've got a raised hand from Robert Prokop.
Brother Guy, a question I've always wondered. I know that you take the meteorites and you could trace them back to Vesta or Mars or some other body out there. Are you ever able to take a group of meteorites and infer from them, from their orbits and their properties, bodies that no longer exist? Extinct asteroids?
The answer is absolutely yes. You mentioned Vesta and Mars and the Moon. Those are the ones we can do, and that's it, period. Beyond that, the best we can do is to say that a class of meteorites look like the surface of a class of asteroids. And there may well be a case where there is one particular asteroid that some people have argued is the most likely source of these ordinary chondrites, but that's very controversial, and there's no consensus on that. What we do have are iron meteorites, which look very much like they were the cores of melted, differentiated asteroids. The fact that we've got them means that they got out from the inside of that planet, which means that something broke up that planet a long time ago. What we've also measured, and this happened in the 90s, there are 2 or 3 different lines of arguments that all converged at the same time. And one of them was work that came out of our lab, showing that the asteroids made up of a certain kind of stuff are half as dense as the rocks that come from those asteroids, which means that the asteroids are not solid bodies, they're piles of rubble. And ultimately, that means that not only are some asteroids, some meteorites, do they come from bodies that don't exist anymore? Essentially, all meteorites come from bodies that don't exist anymore. And indeed, the asteroids themselves are made up of bodies that don't exist anymore, that were broken up and reaccreted. So,
fascinating. Yeah.
It's even deeper than you thought. Great question.
Thank you.
It is possible that Ceres is an original object, and it is possible that Vesta is an original object, but there is somebody who would say that's controversial. And as I'm looking at this, he is next to me on my left. I'm not sure where he is. Yes, it's Brother Guy who has come up with that idea that Vesta is a rubble pile.
A reaccretion of an earlier body.
Reaccretion.
Right. And there are those who would say that Ceres is not really an asteroid, but a dwarf planet.
Let's not go there. But I think there are some iron meteorites that may have come from the asteroid 6 Hebe, but again, that's controversial. And those iron meteorites in general were formed not as cores of planets, but as remelting of the material by a big impact. You have a big impact and you've got a lot of metal and you melt the whole thing, and you do get potentially some iron asteroids, but most of them probably are cores or the interiors of objects that are no longer with us.
Paul Gabor asks about trans-Neptunian objects. Are they rubble piles? And the answer is we're not sure. My guess, having been in the field for a while, is that every time an astronomer tries to get money from NASA to sample some object because it is a pristine sample of the early solar system, they find out it isn't a pristine sample. That the early solar system was a very violent place, and lots of things happened in the first 500 million years that broke stuff up and put it back together.
There was a question of what a TNO is, trans-Neptunian object, i.e. something from beyond Neptune, which includes an exoplanet.
Indeed. There are also a couple of interesting comments about how we're doing and working on getting rid of the idea that the church is anti-science. That's, of course, one of the reasons we exist as an observatory. I'll mention that I've got a couple of books in the works, one that Chris Graney and I have just submitted to Paulus Press about science and religion and the nature of science, and another that I've got a contract for but haven't started writing yet, called The Jesuit Guide to the Sky. It's the sort of thing that we'll never win the fight at one point, at one time. The best we can do is person by person, moment by moment, tell people about the Vatican Observatory and your interest in it and send them to our website. Though it's frustrating. I'll end with this story. One of the things I've been doing this past month was reviewing a book on the history of planetary sciences. One of the editors with a good Irish last name is a historian of science and writes in it about how he was brought up to believe that, the world was 6,000 years old and that St. Augustine had said, God made hell for people who are too curious. I'm going, what? What? Because neither of those things are taught in Catholic schools. He also has written about the history of Angelo Secchi, who was a Catholic priest and a great astronomer of the 19th century. And he himself doesn't see the dissonance between the belief that he has that the church is anti-science and the scientist he has written histories about who is a church person. And he just can't even see that there's a conflict in that because he so deeply believes that, the church is anti-science. On the other hand, as long as there are people out there who think the church is anti-science, then people like me and Paul Gabor will keep having a job. So it can't be all bad.
That's a wrap for this podcast. The audio editor for this podcast was myself, Bob Trembley. You can listen to our other podcasts and read our posts on the web at vaticanobservatory.org. If you'd like to attend our full moon meetups live, join our Sacred Space Astronomy community, also at vaticanobservatory.org. Clear skies, everyone.